Hello, this video is on secants, tangents, and angle measures. We've already talked about tangents, so recall that a tangent is a line that intersects a circle in exactly one point, and it is perpendicular to the radius. A secant is a line that intersects a circle in exactly 2 points. We say secant, okay? And so it's a line that goes through the circle, and of course it contains a chord. So now we know what a secant is, and a tangent. If a secant and a tangent intersect at a point of tangency, the circle will be divided into 2 arcs. 1, 2. The measure of the arc is 2 times the measure of the angle formed on the corresponding side of the intersection. For example, this angle formed right here, say it's 107 degrees, the arc is going to be twice that. So 107 times 2 is 214. Okay, and this angle here is obviously supplementary to the 107, so it would be 73 degrees. But the arc is twice that, so we have 146 degrees. All right, so for example, we're going to label each arc measure and each angle measure. So this arc right here is 130. And I know that I can get the other arc because the whole circle is 360 degrees. I just have to take 360 and subtract the 130 to get the other arc, which is 230 degrees. Okay, now to find the angle measures, this angle here, and again its vertex is on the circle, it is half of the arc that it intercepts. So this one is half of 130, which is 65 degrees. And the other one is half of 230 degrees, so that would make it 115. Here we have a 125 degree angle. And so our arc is going to be 250 degrees, so it's 125 times 2. And our angle is going to be supplementary to the 125, so 180 minus 125 gives me 55. So that's a 55 degree angle. But the arc is twice that, so that's 110 degrees. Just like inscribed angles whose vertex is on the circle, these types of angles that are formed by secants and tangents have their vertex on the circle as well. All right, if we have 2 lines that intersect a circle, there are 3 places where the lines can intersect. The location of the intersection determines the formula used for finding the angles formed. So we have on the circle, where our angle is equal to half of the arc. If it's inside the circle, inside, the angle is equal to half of the sum of the 2 intercepted arcs. And if we have the vertex of our angle on the outside of the circle, the angle is going to equal half of the difference of our intercepted arcs. a lot of times I abbreviate it. Angle equals half of arc minus arc. Back here inside the circle, we have the angle equals half of arc plus arc. And there's usually a big arc and a small arc. And then on the circle, which is also with inscribed angles, we have angle is equal to half of one arc. So these are the formulas that we're going to use. Watch the next video for example problems.